So in this video, we are going to start a discussion on a new chapter. It's called chapter number 13, surface areas and volumes. So we are going to see surface area and volumes of different geometrical figures throughout this chapter. Now all these figures of which we are going to discuss the surface areas and volumes are solid figures, okay, unlike the plane figures that we have seen so far. So far in this entire curriculum of 9th standard, we have seen a lot of plane figures, okay, and we have seen a lot of properties of plane figures. But now in this chapter of surface area and volumes, all we are going to see is solid figures. So first of all, quickly, let us see what is the difference between plane figures and solid figures. So plane figures, to put it in very simple words, plane figures are figures, okay, figures that can be drawn on a plane. Very simple and very straightforward definition. That can be drawn on a plane. What do you mean by that? So for example, if this is my plane, okay, let's draw a random plane, okay, what are the figures? Just think about it. What are the figures that you can draw inside this plane? So for example, you can draw a triangle. So this is a triangle. You can draw a circle. This is a circle. You can draw a square. So this is a square. And you can draw a rectangle. So this is a rectangle. So these figures, in fact, these are the figures that we have seen so far in our discussions. We have seen areas of triangles. We have seen properties of circles. We have seen areas of parallelograms. So all these figures which can be drawn inside a plane, okay, are called as plane figures. Now, what is the definition of a solid figure? So solid figures are the figures, let's use a highlighter, which are three-dimensional, okay. Solid figures are figures which are three-dimensional. So as you can see clearly, these figures, triangle, circle, the square or the rectangle, they're two-dimensional, okay, in this plane. However, solid figures are three-dimensional. Now, what do you mean when you say solid figures are three-dimensional? So here is a figure here is a figure of how a three-dimensional figure comes into a picture. So okay, what we can do is we can just pull it up. Okay, now just focus on how we reached this point. So just imagine first you have taken a rectangular sheet of paper. So I'm going to in fact write the description. So what is this? Okay, what is this? This is a one sheet of paper. Okay, so one sheet of paper, and the shape of this sheet of paper is rectangular. Okay, it's a rectangular sheet of paper. So something similar to like this. Okay, this rectangular sheet of paper is cut out and we have brought it here. Okay, now imagine that we have several such 10 to 12 rectangular sheet of paper placed one above the another, one above the other, and thus just by doing this simple thing of vertical stacking, okay, what has happened here is called vertical stacking. So I'll just write it here, vertical stacking or vertical pile of papers. Okay, so if you put this several sheet of papers one above the other, what you get in the end is one three-dimensional, this word is very important, three-dimensional figure. And this such three-dimensional figures are called as solid figures. Okay, so the figure that you see here is in fact called a cuboid. So I'm just going to give that name to it. This figure is actually called as a cuboid. Okay, so if I ask you what is the definition of cuboid, it's very simple. A cuboid is a geometrical solid figure. Okay, this word is very important. It's a geometrical solid figure which is rectangular in shape. Okay, it's rectangular in shape in all the directions. So this is how you create a solid figure. Now in this entire chapter of, as I said before, I'm just going to re-emphasize the point. In this entire chapter of surface areas and volumes, our focus is on solid figures. Our focus is on three-dimensional figures, figures like this, okay, which we are going to get by vertical stacking of sheets of paper. Now the first figure that we have to focus on, it's called as a cuboid, and we are going to see, let's remove this, we are going to see how to find the surface area of a cuboid. Okay, so I already have a plain cuboid here. Okay, so this is my plain cuboid. Now once again, just to repeat, how is this cuboid coming into picture? This is the one sheet of paper, rectangular sheet of paper, that you will place on the base, on the baseline, and then there will be several other sheets of paper, one above the other, one above the other, one above the other, and finally this will be the last sheet of paper. Okay, and thus you get this, again, a three-dimensional figure, which is called as a solid figure. Okay, so this is our solid figure that we get. Okay, and why is this called as a cuboid? Let me highlight this word. Why is it called as a cuboid? Because of the rectangular shape. This base as a rectangular shape. Now, let's remove this highlighted thing. Okay, and I also erase this. It's a solid figure. Okay, now we have to find, sorry, now we have to find the surface area of this cuboid. So how do you find the surface area of the cuboid? We have to focus on these faces, these different faces that the cuboid has. So I'm going to use the highlighter to mark the different faces. Okay, so first of all, okay, this is my length. I'm going to call this length. Okay, length L, and this, so I'll just use arrow. This, now this is our breadth. Okay, so this is our breadth. Let's call it B, and finally this is our height. Okay, this is the height of the cuboid, height H. Okay, so in fact, we should have used different colors, but okay, that's fine. Let me just change the color of this color. Yes. Okay, so we have height, we have breadth, and we have length of the cuboid. Now, focus on the point that this cuboid has 6 different faces. So I'm going to use a highlighter to mark them. So this is face number 1. Okay, this is face number 2. Both are Note both are equal to each other. Okay, they have the same. Yes, so this has the same length and this has the same breadth. So this is the first face of the cuboid. I mean, two faces of the cuboid. And let me try to zoom out. Yes. Now, what will be the area? So as we know that these are all rectangles. These are all rectangles. So what is the area of this face? Okay, it is length into breadth. So I'm just going to write that. Okay, so let's use a line to mark the demarcation. Yes. So the first face, or let me write, what should I write? Okay, let's use the term face 1. So face 1 is equal to length into breadth. Okay, and I will say face 2 is also equal to length into breadth. Okay, this is the length, this is the breadth. Even for this green highlighted part, this is the length and this is the breadth. Okay, so this becomes our face 1 and face 2. Now let us erase this highlighted part. Okay, yes. Now focus on these two rectangles. So this is the front rectangle that I'm going to highlight here. Okay, and again this is the back rectangle that I'm going to highlight here. Both these rectangles are also the faces of the cuboid. So once again I'm going to write here face 3. Let's call them face 3, face number 3, and face number 4. Both these faces 3 and 4 are equal and they are actually rectangle in shape. Now once again, what is this? This is length. And what is this? This is the height. So L into H will give us the area of this pink rectangle. Similarly, this behind thing also. This is the length, this is the height. This is the length, this is the height. So I'm going to write here length into H and length into H. Okay. Now once again, let's get rid of this. And finally, the sixth face is this one. Okay, and this one. Okay, now what is the area of this rectangle? Area of this rectangle is breadth, this breadth into height. Okay, and area of this rectangle is also this breadth into this height. So once again, this right here face 5 is breadth into height, and face 6 is also equal to breadth into height. Okay, thus if you want to know the, so I'm going to just erase this. Yes, so thus if you want to know the surface area, let's come here. If you want to know the surface area of a cuboid, then we have to do the summation of all the areas of these rectangles. Okay, so in fact, how is that possible? uh, okay, so this is the face 1. Okay, let's use a different color. This is our face 1, this is our face number 2. Okay, then this big rectangle is face number 3, and the behind rectangle is face number 4. Okay, and then this rectangle is face number 5, so I'm going to write a 5, and this is face number 6. Okay, so thus a cuboid has 6 faces, and the surface area is the summation of all the areas of these rectangles. 6 rectangles and their 6 areas, which we have noted down here. So we're going to just continue here. Exactly, so I'm just going to write here. Okay, so we call it total surface area of a cuboid. Okay, of a cuboid will be what? Is the summation of all these 6 faces. So that is in fact going to be 2 times, because there are 2 times length into breadth, okay, plus 2 times length into height, plus 2 times breadth into height. Okay, so this 2 times, this 2 times, and this 2 times, this. Okay, which is equal to, just to make it look a bit better, this is equal to 2 times and then a bracket, length into breadth plus length into height plus breadth into height. Okay, so this becomes, I'm going to use a highlighter now, this becomes our surface area for a cuboid. 2 times, okay, length into breadth, length into height, and breadth into height. Okay, where this is length, this is breadth, and this is height. So if you notice, no matter if you interchange these 3 symbols, okay, like you can say this is the breadth, you can say this is the length, you can say this is the height, or you can say this is the height, this is the length, this is the breadth. It doesn't matter. Even if you interchange these symbols, this is going to be same. This 6 faces is going to come to the same thing, and we are going to get the same formula for the surface area of the cuboid. Okay, so after discussing this surface area of a cuboid, let's come to the third part of this video. Oops. Okay, which is nothing but surface area of a cube. Okay, and cube and cuboid are quite similar in the way they look. So we already have a ready-made cube here. Yes. Now, if you notice, what is the key difference between this cuboid and a cube? The difference is, here there are rectangles. Okay, here there is a square. Okay, so in this figure, instead of taking a rectangular sheet of paper, if you take a square sheet of paper and just do this vertical stacking, you will get a cube instead of cuboid. So that is how you get a cube. And you know the property of cube. In cube, every side is equal to each other. So I'm just going to make a note of that. Okay, this side is equal to this side is equal to this side. Okay, they're all equal to each other. Why? Because it's a square. So we know the property of square, that all the sides are equal to each other. Okay, so all these sides or the edges, all these sides, these edges of the square are equal to each other. So let's say the side of a cube is of the length A. Okay, let's say it is of the length A. So I'm going to erase this. Let's just erase this. Okay. So now, once again, we have to find the surface. Sorry, we have to find the surface. Oops. Yeah, the surface area of a cube. Okay. So even cube has 6 faces. So let's use a highlighter. This is face number 1. Okay. This is face number 2. And what is the area of this face? So it's a square. So okay, so I'm just going to write the area of face 1. Okay, let's say face number 1 is going to be a square, a into a, which is a side into side. This side multiplied by this side is the area of the square. Okay, similarly, the area of face 2 is also going to be equal to a square. Okay, same side into side. In fact, you take anything, now you take this face 3, this is also side into side, and you take this face 4, it is also side into side. Okay, so I'm just going to write here face 3 is also a square side into side, and face 4 is also a square side into side. And finally we have okay, and finally we have this as our face number 5, and this behind square as our face number 6. And again same, their area is also side into side, which is a square. So face 5 is equal to a square, and face number 6 is also equal to a square. And thus the total surface area, so let's make a okay, therefore total surface area of cube is equal to, what is it? It is summation of all these faces. A cube has 6 faces, so summation of all these 6 faces is going to be equal to 6a square. Okay, so let's box it. This is the total surface area of a cube. Okay, and what is the total surface area of a cuboid? This thing, total surface area of cuboid is this formula. Okay, so thus in this entire video we initially saw what is difference between a plane figure and a solid figure, and we just saw two important formulas. One is the surface area of a cuboid, and next is the surface area of the cube. Now using these two formulas we are going to solve many different problems where our given geometrical figure in the exercise is going to be either a cuboid or a cube, and we have to simply use one of these formulas to find its total surface area.